Work 4.1, you guys have some word problems and then some graphs. I'll try to walk you through one of the word problems. We should have some ones like numbers 2 and 3 in our notes, so feel free to look at your notes for those. I'll try to help you with number 1 here. It says, while playing pool, you try to shoot the 8 ball into the corner pocket. Okay. Imagine that a coordinate plane is placed over the pool table. So here's our pool table. The 8 ball is at the point 4, 2, that's where the ball is, and the pocket you're aiming for is at 10, 10. So 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's the pocket we're trying to get the pool ball in. You're going to bounce the ball off the wall at 5, 0. So here's 5, 0, and we are going to bounce the ball off the wall. If you know anything about physics, when things bounce, they bounce off at the same angle that they were going in, and so it'll bounce like this. And so this will make an absolute value graph. Write an equation for the path of the ball. It looks like it's going to hit it. Write an equation for the path of the ball. So B, we have an absolute value function. It's going to be y equals, the vertex is shifted 5 to the right, so it's going to be absolute value of x minus 5, and it's not shifted up any. We need to look for a vertical stretch. Here the slope of the parent function would normally be up by 1 and over by 1. There's a vertical stretch up by 2, of a factor of 2, and so this is a completely appropriate equation. Now, we also could have thought of this as a horizontal compression, where instead of being over by 2 and up by 2, it only went over by 1 and up by 2. And so another equation of this that would have been correct would be x minus 5 inside the parentheses, or inside the absolute value. You could have a 2, which is a vertical compression of 2. Do you make your shot? Well, it looks like it is from the picture, but one thing we can do is we can see, is the point 10, 10 in this equation. And so what we'll do is we'll put in 10 for y and 10 for x. We'll substitute, and we'll see 10 equals 2 times the absolute value of 10 minus 5. 10 minus 5 is 5. The absolute value of 5 is 5. 2 times 5 is 10. And so this equation is true, and so you do make your shot. On the back, let's do this guy. This guy is f of x equals 3 minus 2 absolute value of x. This isn't written in our standard transformation form. I'm going to rearrange it. Instead of writing 3 minus x, we can always write negative x plus 3. And that's what's going on here. It's 3 minus something. And so we're going to rewrite it as that something plus 3. So this is that same equation written differently. And now it's pretty easy to see that it has a shift up by 3. And the shift, there is no shift left or right, so the vertex will be at 0, 3. This is a vertical stretch and a reflection. So the absolute value will be opening down, and instead of going by 1, it'll go over by 1, down by 2, over by 1, down by 2. It has a constant rate of change, and so we can treat it just like we would a linear from here on out. The last thing is we've got a few different graphs we need to write the equation of. I think it makes sense to I'll do the second one here. I think it makes sense to identify the vertex first. The vertex is to the right by 3 and up by 5, so the vertex is at 3, 5. I also noticed that the absolute value is opening down instead of up, and I can either think of it as being vertically compressed or horizontally stretched. Either way, I'll get the right equation. The vertex is at x minus 3. This is a shift to the right by 3, plus 5. And it's going to be negative in front because it is vertically reflected. And let's see, the rate of change would normally be down by 1, but it's not. Instead, it's over by 1, 2, 3, 4, down by 1. So I can either put negative 1/4 like that. That would be a vertical stretch, or I could think of it as a horizontal stretch, which would be negative absolute value of 1/4 times x minus 3 plus 5. Notice that this needs to be in parentheses for the vertical stretch, horizontal stretch, I'm sorry. I hope that helps.